My name is Javier Garcia, and I will introduce you some concepts on the robot framework and the CI/CD pipeline that we use in OSM. First, let's start with a brief introduction to the CI/CD pipeline, the different stages that we use, so you get to know the bigger picture of what's happening when you submit a piece of code or any kind of contribution. So for those of you who don't know, the OSM code is built using the typical CI/CD pipeline, DevOps pipeline. Everything is being automated, controlled mainly via Jenkins. So everything, if you're familiar with the DevOps workflow, you will be familiar with this. Every commit, every submission to the CI/CD requires validation of the module leaders. And of course, whenever you submit a code, it will process some checks, some tests, and based on that output, the feedback will be get back to you. Some of the tools that are used in the CI/CD pipeline are basically Jenkins, which is the main brains of this workflow, Dockers for obvious reasons, Fossology for the quality of the code, the Artifactory to store some JFrog Artifactory to store some binaries, Robot Framework, which is what we are going to deep dive a little bit later on. It's for testing, and also some custom scripts to do some validation and more testing as well. The last part is the Etsy Hive. So one of the stages, the final one, runs on the themes that are available in the Etsy Hive. So this is the big picture of the whole pipeline. As you see, the top left, there's the developers working on some commits. Whenever they introduce a new commit into the Gerrit, then you see there are four stages. First one, just triggers different validation workflows for each module. Right? Just basically routing the right workflows. Then they go to stage 2, which the different unit tests and individual tests for the component that you've modified, that you submitted your code, are done. Multiple workflows can be run in parallel using Docker, so containers are run, some unit tests are run inside the module to check that everything is fine. If everything passes that, then some artifacts will be generated and will be uploaded to the JFrog Artifactory, and the next stage will be triggered. So next stage is just basically running and the whole OSM with the new modules that you've modified. And in this stage is where Robot Framework, among other manual tests using Python, are run. This tests the whole OSM. So typically, after this stage, Jenkins will produce an output coming back to the developer using the Gerrit, and it will inform you if your code has been successfully tested or not. If so, then it will go to stage 4, in which the Etsy Hive comes into place. So the whole OSM will be deployed in a live VIM, and several end-to-end tests will be done there. So you can test the actual functionality in a live environment. So let me go into each stage again. So I was saying, stage 1, launch stage. So whenever you submit a code to the Gerrit, this will be triggered, or whatever code or patch or whatever kind of contribution that you submit to the Gerrit. So different branches will be triggered depending on the module that you've modified, or the modules that are needed to complement your code, and stage 2 starts. So, as I was saying, using Dockers, different modules are deployed and tested unitarily, right? Different unit tests, and if all of those tests are passed, then a package, an artifact, will be generated with the modifications that you've submitted, and it will be uploaded into the repository. If that is fine, then Jenkins will trigger the next stage. Stage 3, system integration. So we get the modules that you've modified, put them all together, have a complete OSM deployment, and test it. Do some smoke tests to verify the very basic functionality of OSM. It's still intact and works perfectly. In this case, up to now, we've been using PyTest to run the tests, but very recently, for this next OSM release, we are starting to use Robot Framework, which I will go into more details later, but basically it's a testing framework that makes your life much easier when you want to test, in this case, OSM, to create tests and run them automatically, so pretty handy. So at this stage, as I was saying before, if everything passes, then you will get a +1 in the Garcia. So Jenkins will say, okay, that's fine. Your code runs, it does not break anything. Daily, once per day, the stage 4 is run. Stage 4 runs the whole OSM into a live VIM, as I was saying before. So those live VIMs are the ones that are available in the Etsy Hive. So there are multiple VIMs available, OpenStack, VMware, different kind of combination of SDN, depending on the feature that you've submitted your code. So the whole OSM, with the modifications that you've done, will be run in a live environment. Okay, so now we know more or less how the workflow goes. Let's go a little bit more in detail on this robot framework. I was planning some kind of hands-on session, so you will find available in the FTP some kind of scripts. If you want to follow along, then you're welcome. So what is robot framework? Well, this is more or less what we will be covering. The robot framework, how to set up, which it's for you, it's already set up, so that's even better. How to execute a test suite that's already available in the DevOps folder in the OSM. I will explain to you some of the basics of how to create your own tests. And we will cover both a simple CLI test and a UI test. So what is Robot Framework? As I was saying, it's a test automation framework. Key point here is that open source. So everyone can use it, it's free to download. It's typically used for end-to-end testing, even though you can cover pretty much whatever you want. But the good features of Robot Framework is that you can use it to cover the whole workflow from beginning to the end in a live environment. One of its key features is that it uses human readable tests. So you will see them later, and it's whenever you open a test case, you will find it relatively easy to understand what's going on. And it follows a keyword style of test defining, of test definition. And also, this is very important, uses what is called here a tabular style. So it uses spaces and tabs to actually separate the keywords. This is, at the beginning, this is very tricky because you always forget, and I also do, to put some spaces, or you put so many, so few, and then the robot doesn't know what's going on. But there are some IDEs that help you with that as well, and with a little bit of careful, you will find it very, very easy to work with. Why we've used in Robot Framework? Well, as I was saying, it's keyword driven, so it is pretty easy to read and to develop tests for this. You can use keywords, you can reuse them, so you have to create them once for your test and then reuse them in many test suites that you want. So this is very useful for automation. Custom keywords. Robot Framework is built on Python, so if you want to develop, there are lots of public libraries already available, but if you, for some reason, find that whatever you want to do is not covered, then you can use Python to just execute whatever kind of test you want. As it is built on Python, it is, of course, platform independent, so very useful as well. There's a lot of already available libraries for the operating system, for any kind of third-party systems. That's on the website. You will find a lot of things. It uses tags to categorize the different test cases, which is also very useful because you may have a bunch of test cases, and you want to only maybe trigger, depending on the stage in which you are, some kind of special triggers. For example, in this case of OSM, we will see So test cases for the VIM, test cases for the descriptors, test cases for the instantiation of VNFs. You can filter those using tags. And also the output of the results, it's automatically generated in HTML format, which is also a nice way of seeing the results. Let's see. So I have this slide here at least for you to know more or less the commands that are used to set up robot. If you're using the VMs that are provided to you in this Hackfest, this is already done for you. If you plan to follow along, then I will suggest you to run robot -- version to make sure that robot is installed. It should be. If not, well, I guess you have the commands here, just basically using pip to install the different modules. Apart from robot, you also have one web server like HTTPD installed as well to see the results of the test cases. So each one of you, if you want to generate the output, you can use a folder, you can create a folder in the temp TMP directory, and you can put the results there. I will explain to you later on how to do it. The port that it's already configured in the VMs that you're using is the 8088. Okay, so the first step, I thought it would be interesting to use whatever is already available in the DevOps folder. So if you clone the DevOps repository from OSM, you will see that there are different folders there. But if you go under robot sys_test/test suite, you will find different tests that are already available. You can use them, explore them, and learn a little bit more how they're done. To actually execute one, just make sure that in your environment variables, there's this OSM_hostname. It's needed to run the test. So for robot to actually know where the OSM instance is running, basically. It should be available in your environment, in the VMs that you're using. So if you have those ready, you have the DevOps folder, the DevOps module cloned in your VM, and you have the environment variable, then you should be able to execute the command that's below. So in this case, basic execution of a command, it's just robot, the keyword, to actually call robot framework. Then -d is where you want to output your results, your HTML results. In this case, I was using robot sys_test reports, but you should use /temp/ whatever folder you want to use. -i VIM in this case is that I'm saying robot to use only the test cases that are tagged with the VIM label. And the rest is basically the path to a robot framework, which is already available. So you will see it's sys_test, test suite, or there's a /mission, or that's the application test, robot sys_test, test suite, /CLI, /TS02, test VIM. So you will see there are lots of tests there. So in this case, we are running the tag with VIM, but you will see that there are more tags that are being used, like for example, this comprehensive tab. If you use it, they will run a lot of different tests. So everything is being available, thank you, Series, in the path as well. All these commands, if you're following using them. Okay. So if you execute that, and everything goes well, which should be, this is what you will see. This is the output. Basically, what this test suite is doing is creating a dummy VIM in OSM using the CLI command. It's listing them and then delete them. Just very simple test, but useful to know if OSM at least is running and VIMs can be added. So you will see the output of the command. You will see different sections according to different tests test cases that are defined in the test suite. And you will get a pass or a fail, depending on the result for each of the stages. Right? At the bottom of the output, you will see the path of the output folder. So you will get you get three, one in XML format, and the other two, which are the interesting ones, which are more easy to read, in HTML format. So if you specify the folder in the output folder in the temp, if you go to the web browser with the port 8088 / and the path that you've created, you should be able to see one of those, the log.html or the report.html. The report is like an overall view of the whole test suite. And if you want to go into more details, you go into the log.html, and if for some reason anything failed to you, you can just go there and see what was going on. You will get more detailed information of the commands and the output of the commands that you run. So that was the executing a test suite that is already available in the DevOps folder, DevOps community. But let's go a little bit more into what's going on. So let's try to open that file, the global file, and understand a little bit more what's going on. So there are 4 different sections, mainly in the robot test suite. They are all text plain, test based, so easy to read. First section, it's settings. So this is the typical section to import different libraries or finding metadata. You will find this section everywhere in the different robot files. Then section variables. If you want to use any kind of variable, for example, login credentials, IP addresses, whatever, you will define them here. Then the different test cases. This is the huge part of the file. So different test cases are created using the keywords, and those keywords can be found either because you've imported them at the beginning or because you've defined them at the bottom in the keyword section. So there at the bottom, you create your own keywords if they're not available, and then you can use them in the test cases. So let's go a little bit more detail on the different sections. So as I was saying, the settings at the beginning, it's for importing different libraries or defining some kind of metadata. So the format that it uses is that the section is like three stars, space settings, and then 3 stars. That's the way it is defined in Robot Framework. So if you have the file opened, you'll see that it's pretty easy to follow. Of course, there's the section of documentation, which is always encouraged to do if you're defining your own test cases. And then different libraries. For example, here we have the operating system, which provides some commands to access environment variables or access to the CLI of the system. The way to import different libraries or resources is pretty easy. So for libraries, you use library, then tab the library name, tab and different arguments if needed. For resources, it's same resource tab and then the path of the file that you want to include. For example, you may want to include different robot framework in which you have defined keywords. You may have one robot framework with only keywords and then use another one to import them and use them. So this is the way you can do it. Then there's setup and teardown options. Setup are actions that are triggered whenever you run at the beginning, whenever you run the test. They're done at the beginning every time, and the teardown at the end. So whenever you finish the test suite, whatever you've specified there will be triggered. And then different tags. So you can force a tag for the whole test suite. Next one, variables. So as I was saying, since robot is built on Python, the variables that you can create are pretty much the ones that you can create on Python. So you have the typical scalar values or string values. You have lists and you have dictionaries. The way to create them is just for scalar or string variables, you put $, and then between curly brackets, you put the variable name and then tab and the value. whatever you want to put there. For the list, you simply do the dollar and you put an @ symbol. And to access them is just, as you may expect, you use the dollar brackets and then between square brackets the index, as you would do in kind of Python language. And the dictionaries is just substituting the first symbol with an AND symbol. And again, between the tabs, you define your variables. So the key equal the value. And to access them is the same as for the list. So you have a bunch of different options for you to use. Test cases, this is the important one. So as you're seeing, the different sections are highlighted using 3 stars, space, test cases, 3 stars. And here in this section, you define your actual test cases, the ones that you're going to run. There are different sections at the beginning. So you have documentation, always encouraged to use. Different tags. So I was saying you can tag each of the test cases individually. You have also, each test case has its own setup and TLL functions, in case you don't want them for the whole test suite, only for a test case. You can define templates. As I was saying before, you may import them. You can use keywords that are important from other files, or timeouts as well, if you're just expecting the test case to time out. And the format that you're seeing is just, you put the name of the test, in this case, for example, my test, then in a new line and using tabs to make sure that everything that you put is inside this test, the different sections. So documentation between square brackets, tabs, and the whole text that you want to put there. And then below is the keyword. In this case, it's using log, tab, and the message to log. And the second one is another keyword that we have defined somewhere else. And this is the format. So if you have the files open, if you open one of those files that are in the DevOps folder, you will see the same structure, which is pretty, as I was saying before, pretty easy to read. And finally, the keywords. So if you want to define your own keywords to use them in the test files, this is the section in which you define them. So basically, again, 3 stars, space keywords, space 3 stars, and then you define your keyword. In this case, the keyword is my keyword. And then you put the commands. So in this case, the arguments, this keyword is expecting one argument, which is the path, variable path. And then the command that is going to execute is called, or the test that is going to execute, directory should exist. This keyword is defined in the basic system library of robot. And it's checking basically that the path that you've input as a variable exists. And instead of using directory should exist, now you can use my keyword to trigger this action. So for this session, I prepared some libraries for you to use. They're available in the FTP. You use wget.url and unzip it. You will find 4 files. 2 of them are test cases. 2 others are, I call them libraries. So they contain keywords for you to use. And that way you see how to import different libraries and keywords for your file. You want to say something?
The mic.
So it isn't recording anything. Okay. I'm going to start again. Okay, so if you download that zip file and you unzip it, as I was saying, you will find 4 files, and we will go into to see them now. So let's create a simple VIM test following the test case that we've executed before. In this case, using the OSM CLI. So here, let's call it hackfest_test.robot. So these are the contents of the file. You have them already available if you don't want to type them, these lines. But what we are doing basically is on the settings part, we are creating we put some documentation. We are importing 2 different libraries, collections and operating system. with auxiliary functions that will be useful. And we are importing one of the other files, which we are using resource, and then OSM CLI lib.robot. This one provides commands for to use OSM using the CLI. In the variables, here you see we define some success return code as 0, and we have different variables for the test. So the VIM name, the VIM user, the password, the auth. So if you are trying this in your VM, make sure that these parameters are correct. Just don't copy paste blindly these ones because they may not work for you. Just make sure that the URLs and the names and everything are correct. We will use these variables in the test cases. So here in the test cases section, we are defining 3 test cases. The first one is create VIM account. We've tagged it with the VIM tag. And if you see the actual command that it's running is create VIM CLI, and then we use the different variables that we've defined before. So where is this create VIM CLI? In this case, it's in the library that we've imported before. The OSM underscore CLI underscore lib contains the keyword create VIM CLI. So we are just calling that keyword from here. Next one, we list the different VIM accounts to make sure that the one that we've created is being correctly added. And again, we are tagging it with the VIM tag, and the actual command is get VIM list CLI. And finally, to avoid messing up with the OSM instance, we are deleting what we've just created using the delete VIM CLI. So to know actually what this create VIM CLI, list CLI, and delete VIM CLI actually do, you can go into the, as I was saying, this OSM CLI lib.robot, and you will see there the action happening. But these are the test cases defined. So this is, I would say, pretty simple. So if you execute this test with the same syntax that we used before, robot, then -d to specify the output directory for the HTML files, and then -i for the tag, then the name of the actual file, you will see it should work. And you will see that everything is passed, and we are basically replicating what you've executed before, right? So creating the VIM, listing them, and deleting. So the outputs, if you want a more detailed output of what robot did for this test, you can go to a web browser and go to the whatever IP that you're using. The port is 8088, as I was saying before, and then / the folder / report.html for an overall view of the whole test suite. And if you want more detailed steps on each of the different test cases that you've defined, you go into log.html. So up to now, we've tested OSM using the CLI, using the OSM command. In this case, I had other example, which is using the GUI. If you, for some reason, want to test the OSM using the CLI, you can do that as well using robot pretty easily. In this case, you need to have Selenium test framework installed. Lucky for you, this is already prepared in your virtual machines. But basically, what you need is, if you see the commands, you need a browser. In this case, we are using Chrome. And the driver, the Selenium driver that robot will use. So this is another file in the zip folder that you've downloaded from the FTP, but in this case, to actually add those tests to the one that we've created before, it's just pretty simple. You just need to add that library, Selenium library, to the test suite that you were preparing before. In this case, we are adding another resource, which is OSM underscore GUI underscore lib. In this case, it has functions to use the GUI of OSM as opposed to the CLI. And then we need 3 more variables, which are OSM host, OSM user, and OSM password. So what this test will do. This test will use, sorry, this test will use the keywords that are defined in the Selenium library to open a browser, go into the OSM URL, input the credentials in the web form, and then enter. And if everything goes well, it should be in the main OSM web page. So this will done that automatically. If you see the test case, we've called valid login. We've put a tag GUI login test. And the setup, in this case, we are asking Selenium to set the server URL for OSM in this case. So as you see, then the keywords are pretty self-explanatory. So the next one is open browser to login page. The login page is the one that we've said before. Then enter credentials, which are OSM user and OSM password. It's like as if you were typing them into the web form. Then submit credentials, which is simulating clicking on the enter button. And then there's another one which is homepage should be open. Homepage is defined in the auxiliary library to be the main OSM page. So if everything matches, this means that the login works and the OSM GUI works. So then the final one is just to close the browser. And this is the test to make sure that the OSM GUI is running. This is, of course, very simple, but if for some reason you want to test some more complex functionality using the GUI, instead of you going manually, it's on the steps, you can just write the commands here and let the robot do it for you. So to execute that, in this case, please. In this case, we are using the tag UI login test that we've specified before. Or if you have created your own file, then you don't need the tag, and you just select the file that you've selected. So the output should work. If you have OSM running, this shouldn't be complex. And you will see everything is passed, and the output's in the temp folder that you've selected before. If for some reason it doesn't work for you, then don't worry. Just go to these HTML outputs, and specifically to the log one, log.html, and you will see detailed information there of what robot tried to do and what it failed, where it failed, with detailed information. In this case, for example, if you use it with the Selenium library, if there's a failure for some reason, Robot Framework will use Selenium to make a screenshot at the time it failed. So you will see if, I don't know, for some reason it went to Amazon.com or whatever. So you will see that, get a screenshot. Okay, so I hope anyone, I don't know if you have any questions or not. I think more or less it was relatively easy to follow. These are some useful references that you may use if you want to deep dive more into Robot Framework. There's plenty of information available online. You have here some links to the GitHub, to the documentation, the user guide, and everything. And of course, we were using simple text editors to create these tests. But if you plan to do more, or you plan to be a little bit more serious on that, you can use IDEs, some specialized editors that are available in the official web page. But well, there are some. Just pick and choose where you feel like. The good thing is that you have auto-completion, you have validation, syntax validation. It may make things easier for you if you plan to develop more test cases. Another thing, if you are more interested in this DevOps workflow and the test execution, different stages, you can join the community using the DevOps. So you have the DevOps channel on the public Slack. And of course, you are more than welcome to join the bi-weekly calls that we have in OSM, scheduled specifically for the DevOps talk. If you have any comment, any suggestion, or you just want to know more of what's going on here on this DevOps section of the community, just feel free to join any of these channels. So this is all from my side. I don't know if you have any questions. If not, then that's it. Yes? Thank you. It's basically automation. So most of the tests already are written in Python. The thing is that to test the end-to-end OSM with Python, it's a little bit more complex, only using plain Python. Because Python for a unit test, okay, that's fine, that you can use it. But maybe for end-to-end, in which you have, for example, you want to test the GUI, for example, or you want to test, I don't know, whatever, the whole workflow of adding the VIM, adding the packages, instantiating the packages, testing in the, for example, the OpenStack, that everything's fine. You know, what we've covered here is pretty simple, but whenever you start to add more tests with robot, then it's pretty simple because robot allows you to just execute robot, the folder that you want to execute, and depending on the stage, for example, you just say, okay, comprehensive, I want to test everything, and you just let robot run for different hours, and then you will get these HTML outputs with every detailed information of the different test cases inside. So, and also the creation of the test cases, as you saw, using these keywords, it's, at least in my opinion, it's much simpler. So you don't actually need to be a very good Python programmer to use robot. You just need to understand the workflow and, okay, so which keywords do I have available? So in the DevOps folder on the community, there are lots of already available keywords to test OSM. You just need to write open VIM, create instantiate network service, instantiate BNF. And you don't need to know Python at all. You just need to write the keywords. So I think that's the benefit of using robot in this case, automation. Anything else? No. ¿Vamos bien? Ya, bueno, es que no había... Okay, thank you very much.